All right, so now that we've discussed graphing quadratics from standard form, we're going to review how to graph quadratics from vertex form. You learned that in Algebra 1. And then I'm going to show you another form, intercept form, and show you how easy it can be to graph in that form as well. All right, so reminder, vertex form looks like y equals a, parentheses, x minus h, parentheses, squared plus k. And a is still going to tell us whether the parabola opens up or down. And remember that HK is our vertex, just like it was for the absolute value. And our axis of symmetry, remember that's that dotted line we draw through the middle of our parabola. That's just going to be x equals h. So it will always go through that vertex. So let's do an example. So our first example, notice that our A is positive, so that means it's going to open up. And I'm going to identify my h and my k. So this is my h, this is my k. So I'm going to first of all draw my axis of symmetry. That's what AOS stands for, axis of symmetry. And I know that my axis of symmetry is the line x equals whatever my h is. So our h is positive 3. Why is it positive? Remember, it's always opposite of the number in parentheses. So we had x minus 3, so my h is positive 3. So I'm going to draw a vertical line at x equals 3. So that's my axis of symmetry. So I know the parabola is going to be cut in half right there. Then I'm going to plot my vertex. Well, remember our vertex is h comma k. So I'm going to have 3 comma negative 5. I'm going to plot that on my graph. So if I go to 3 and then negative 5, 1, 2, 3, 4, 5, that's right there. That's my vertex. Then what I'm going to do is plot 2 points, one on each side. Now I say pick 0. Sometimes it's easier to plug in 0, but on this one actually, I'm not going to do that because it comes out to be a really large number and I can't fit it on my graph. So I'm just going to pick a number on either side. So remember when we were doing in standard form, we would put our vertex in the middle there, and then I would pick a number on either side, so like 2 and 4. So I need to figure out what my y coordinates of this point is. So if my x is 2, I'm going to plug in 2 into my equation. So we're rewriting our equation, but instead of x, I'm plugging in 2. And remember, I'm getting that equation all the way up here from the original problem. That's where I'm plugging in. All right, so all I have to do is evaluate, and we've done this a bunch of times. So 2 minus 3 is negative 1 squared. Now I'm going to do the exponent, so that's negative 1 squared is positive 1. And then I'm going to have 2 times 1 is 2, and then minus 5 is negative 3. So I know my y coordinate is negative 3. And remember from the previous lesson that we know that this should match down here. These match. So when I go to plot my points, I'm going to go to 2, negative 3, 2, negative 3, 1, 2, 3. That's there. And then my symmetrical point is 4, negative 3. That would be right there. So I can draw my parabola through those 3 points. And notice that it opens up just like we thought it would. All right, let's do another one. So we're going to graph this equation. Notice that this is A is negative, so it's going to open down. And I'm going to pick out my H and my K. So my axis of symmetry, my AOS, that is going to be the equation x equals h. Now remember, it's opposite of that number in parentheses, so that's negative 2. So I'm going to put a dotted line on x equals negative 2. Now I'm going to plot my vertex. So my vertex is h comma k, so that's going to be negative 2 comma 6. So if I go to there, 1, 2, 3, 4, 5, 6, that's right there. And then I'm going to pick some points on either side of my vertex. So remember, my vertex is in the middle, negative 2 comma 6. And I'm just going to pick some points. So negative 3 would be lower and negative 1 would be higher than that. So we just plug those into our equation. What equation do we use? The original one that they gave us. This is the one we're plugging into to find our y value. So I'm going to have y equals, I have a -2, and then instead of x, I'm going to just plug in -3. So -3 plus 2 squared plus 6. So if I do that, I get -2. Inside parentheses, I have -1 squared. Now I'm going to do my exponent. -1 squared is +1. And then -2 times 1 is -2. And then if I add those together, that gives me +4. So I'm getting +4 here, and I should get the same thing here. These should match. So I'm going to plot those on my graph. So -3, 4, 1, 2, 3, 4 is there. And my symmetrical point is -1, 4. That should be there. And notice that our parabola opens downward just like we thought from the beginning. So that's a reminder of vertex form. So vertex form allows us to identify the h and k very easily, and then we can plot points. The next form is intercept form. Notice that intercept form looks very different. It looks like two parentheses multiplied together. So it doesn't have a squared anywhere. So in intercept form, we still have a number in front of the parentheses. That's our a, and that still tells us whether the graph opens up or down. And then these numbers inside the parentheses, the p and the q, those are going to be our x-intercepts. Remember, x-intercepts are where the parabola crosses the x-axis. Okay, and then we'll be able to find the vertex by going exactly halfway in between those x-intercepts. Okay, smack dab in the middle. And I'll show you what that looks like with this first example. So in this first example, my a, it's not written, but it's understood to be 1. So this means that since it's positive, that our parabola is going to open up. And our p and q are, remember, they're opposite of what inside the parentheses. So my p is the opposite of that +2, so that's -2. And my q is the opposite of the -4, so that's +4. So those are the numbers I'm going to put on my x-axis. So these go on the x-axis. All right, so I'm going to put a dot on -2 and then a dot on +4. All right, so I know my parabola is going to cross the x-axis at those points. And now I need to figure out where the axis of symmetry is. That's the middle. Well, you can do that a few ways. You can look on your graph and count. Okay, I've got 1, 2, 3, 4, 5, 6 boxes in between those. So halfway is going to be 3 boxes in. So you could, if you're good with mental math like that, you can do that. Or if that's a little bit difficult for you, you can average your P and your Q. So when I say average, remember that just means that you add them up and divide by how many there are. So if I just have P and Q, those numbers, I'm just going to add those up and divide by 2. So if I do that in my situation, that would be -2 plus 4 divided by 2. -2 plus 4 is +2. And if I do 2 divided by 2, that gives me 1. So you can see that's the same thing we got by doing it visually from the graph. So my axis of symmetry is the equation x equals 1, right here. It's the equation x equals 1. And then I have to find my vertex. Remember, my vertex is going to be anywhere along this axis of symmetry. So it could be somewhere along here. We know that this has to open up, so it has to be below the x-axis, but I don't know where. So in order to get the exact y-coordinate, I need to plug that in. So my x value comes from my axis of symmetry. So I'm going to use this to plug into my equation. What equation am I talking about? Remember, that's always the original equation that they gave us, this equation right here. So that's the equation I'm going to use to get my y-coordinate. So I'm going to have y equals, you don't have to write the 1, you can. But now instead of x, I'm plugging in my axis of symmetry. My axis of symmetry was x equals 1. So I'm going to plug in 1 plus 2 And then I'm going to plug in 1 minus 4. Notice I plugged in 1 everywhere where I saw an x. Now we're just going to evaluate. So I'm going to have 1 plus 2 is 3. 1 minus 4 is negative 3. So if I multiply all those together, that gives me negative 9. So remember, this is my y, right? I plug this in to get a y value. So I've got an x value and a y value. That is my vertex. So my vertex is 1 comma negative 9. So I can plot that on here. That's right there. And now I can draw my parabola. All right, so let's do that one more time. Get used to that. Here's our new equation. Notice that I have an a value that's negative 1. It's not written, but since it's negative, that means our parabola is going to open down. We need to identify our p and our q. So p is positive 2, q is positive 5. So I'm going to put those on my graph. There's 2, there's 5. And then I need to find my axis of symmetry, my middle point. So my axis of symmetry, that's going to, if I add those together and divide by 2, that gives me 7 divided by 2, which is 3.5. Or you could look, what is right in the middle between there? It's right there. So it's okay to have 3.5. I intentionally did a decimal in case this happens to you when you're doing your homework or your practice problems. So our axis of symmetry is at 3.5, and our vertex is going to be somewhere on there. So now we have to use our equation. Here's our equation, right? The original equation. I have to use this equation, and what am I going to plug in for these x's? I'm going to plug in that 3.5 from my axis of symmetry. So I'm going to say y equals negative 1, 3.5 minus 2, and then 3.5 minus 5. Now I'm going to evaluate that. So if I do 3.5 minus 2, that gives me 1.5. And then if I do 3.5 minus 5, that gives me negative 1.5. And if I multiply all those together, and feel free to use a calculator if you're uneasy with those decimals, then that's going to give me a positive 2.25. So, whoa, what does that mean? That's our y coordinate, right? So our vertex is the point 3.5, comma, 2.25. So all I have to do is plot that. So I'm going to go to my axis of symmetry and go up to 2.25. 1, 2, and just estimate where you think 2.25 is. It's a little bit past 2, but not all the way up to 3. And notice it opens downward just like we thought it did. So that's 2 different ways to graph the quadratic equation besides the standard form.